The aviation world just witnessed something nobody saw coming. March 2025, Pilatus walks into the FAA with a single-engine turboprop that does the impossible. An aircraft that lands itself if you pass out. A luxury cabin that transforms into a cargo hauler in minutes. A machine accessing 5,000 airports where $50 million jets fear to land. But here's what they're not telling you. Just months before this revolutionary aircraft hit the market, 7 people died in a PC-12 crash that sent investigators scrambling for answers. A 10,000 foot per minute death spiral that raised questions nobody wanted to ask. Now Pilatus claims they've solved everything with the PC-12 Pro, the most advanced single-engine aircraft ever built. But after what happened in Wyoming, can we really trust a computer to save our lives at 30,000 feet? What you're about to discover will change everything you thought you knew about aviation safety, and it all starts with 3 massive touchscreens that broke every rule in cockpit design.
For 3 years, over 100 Pilatus engineers worked in complete silence. No press releases, no leaked photos, no industry buzz. They were developing something that would either revolutionize single-engine aviation or become the most expensive mistake in the company's 70-year history. Here's what makes this insane. Pilatus had already delivered over 2,100 PC-12s worldwide. The aircraft was a proven success. Operators loved it. Resale values were astronomical. So why risk everything on a complete redesign? Because they saw what was coming. Beechcraft announced the Denali back in 2016, promising to crush the PC-12 with superior technology. Daher's TBM series was getting faster and more refined. The competition was closing in, and Pilatus knew their aging avionics package was becoming a liability. But here's the controversial part. They didn't just upgrade the existing system, they ripped out everything. Decades of Honeywell partnership gone. The entire cockpit architecture that pilots knew and trusted, scrapped. They bet the company's reputation on Garmin's unproven G3000 Prime system. Industry insiders called it reckless. Some longtime PC-12 operators were furious, and the timing couldn't have been worse, because while Pilatus was finalizing their revolutionary cockpit, a PC-12 was about to fall from the sky in Wyoming, and the investigation would reveal something that made everyone question autopilot technology. But we'll get to that nightmare in a moment. First, you need to see what Pilatus built behind those closed doors.
Step inside the PC-12 Pro and your brain struggles to process what you're seeing. 3 14-inch touchscreens dominate your entire field of vision. This isn't just bigger displays. This is the world's first certified Garmin G3000 Prime system in any aircraft, and it changes everything. Each screen responds to 10 simultaneous touch inputs. That means during critical moments, both pilots can work the same display without fighting for control. Aviation has never seen anything like this. But Pilatus didn't stop there. They added hand stabilization technology that lets you rest your palm directly on the screen during turbulence while making precise inputs. Sounds simple, right? Wrong. This required 18 months of engineering just to make it work reliably. The processing power is staggering, 4 times the RAM of previous systems, 100 times faster connectivity. This cockpit processes more data per second than aircraft costing 3 times as much. And here's the detail that separates Swiss engineering from everyone else. They borrowed the yoke design directly from their PC-24 jet. In a turboprop, that's like putting Formula One steering in a pickup truck. It shouldn't work, but it does. Now here's what Pilatus won't advertise. If you own an older PC-12 NGX, you cannot upgrade to this system. The airframe integration is too complex. The wiring is completely different. You're stuck with your old avionics forever. But none of this matters if the automation fails. And that's exactly what happened at 26,000 feet over Wyoming when a routine flight turned into every pilot's worst nightmare.
Let's talk about the technology that's dividing the aviation community, Autoland. Press one button and the PC-12 Pro will select the nearest suitable airport, avoid terrain and weather, perform a complete autonomous landing, and bring the aircraft to a full stop on the runway. Your grandmother with zero flying experience could theoretically save everyone on board. Sounds like science fiction, but it's certified and available right now. Here's how it actually works. The system continuously monitors pilot inputs through dozens of sensors: heart rate, control movements, response times. If it detects incapacitation or if a passenger activates emergency Autoland, the aircraft takes over completely. It calculates fuel remaining, evaluates weather at multiple airports, checks runway lengths, and makes the decision for you. Then it flies the entire approach, lands, brakes, and shuts down the engine, all while transmitting emergency alerts to air traffic control. But here's what nobody's discussing. Early PC-12 Pro deliveries in late 2025 shipped without Autoland activated. Buyers paid full price for an aircraft advertised with this life-saving technology, but Pilatus needed additional months for final certification tweaks. The retrofit happened in Q1 2026, but some owners are still waiting. And the timing of these delays raises uncomfortable questions, because just 14 months before the Pro launched, a PC-12 NGX experienced an autopilot malfunction that killed 7 people in seconds. The kind of failure that makes you wonder if we're putting too much trust in computers. What happened that day would haunt investigators and change how Pilatus approached every safety system in the Pro.
July 26, 2024. A PC-12 NGX departs from Nebraska carrying 7 souls, among them members of the Nellens, a beloved gospel group. Destination? Montana. It should have been a routine 2-hour flight. At 1:04 p.m. Mountain Time, the aircraft is cruising smoothly at 26,000 feet. Then, everything goes wrong. Flight tracking data shows the aircraft suddenly pitching nose down. Not a gentle descent, a violent, uncontrolled plunge. 10,000 feet per minute. That's nearly 2 miles of altitude lost every 60 seconds. Passengers experienced forces their bodies weren't designed to handle. The aircraft screamed toward the earth near Gillette, Wyoming, spiraling out of control. Impact was catastrophic. No survivors. The wreckage scattered across remote terrain told a story investigators dreaded. Preliminary reports pointed to an autopilot anomaly. Something in the system failed at the worst possible moment, and the pilots couldn't recover in time. The NTSB is still piecing together exactly what happened, but here's what we know. Modern autopilots are supposed to fail safely. If something goes wrong, they disconnect and return control to the pilots with clear warnings. This one didn't, and that's terrifying, because the PC-12 has been one of the safest single-engine turboprops ever built. Over 50 million flight hours accumulated across the fleet. But this accident exposed a vulnerability nobody wanted to acknowledge. What happens when the computers we trust with our lives make a decision we can't override fast enough? Pilatus was already deep into PC-12 Pro development when this tragedy occurred. Every safety engineer at the company knew they had to address this. The Autoland system, the electronic stability protection, the enhanced monitoring, all of it got extra scrutiny after Wyoming. But can software really prevent what happened that day? Or are we just adding more complexity to a system that's supposed to save us?
Let's cut through the marketing and talk real numbers. The PC-12 Pro cruises at 290 knots true airspeed. That's 537 kilometers per hour. Fast for a single-engine turboprop, but here's the truth. The Dare TBM 960 hits 330 knots. That's a 40-knot difference, which means on a 1,000-mile trip, the TBM arrives nearly an hour earlier. So why does Pilatus keep bragging about performance? Because speed isn't everything. The PC-12 Pro needs only 2,485 feet of runway at maximum gross weight. Most competing twin turboprops require 3,500 feet or more. That 1,000-foot difference unlocks access to over 5,000 airports worldwide that jets simply cannot reach, remote fishing lodges in Alaska, private grass strips in Montana, gravel runways in the Australian outback. The PC-12 Pro goes where $50 million aircraft feared to land.
Range is where things get interesting. With 4 passengers and their luggage, you're looking at 1,765 nautical miles maximum. That's New York to Denver non-stop, London to the Mediterranean without refueling. But here's what the brochures don't emphasize. Load 8 passengers with full luggage and that range drops significantly. You're looking at closer to 1,400 nautical miles in real-world conditions. Still impressive, but not the hero numbers Pilatus advertises. The service ceiling hits 30,000 feet, putting you above most weather and traffic. Rate of climb is a respectable 1,920 feet per minute, getting you to altitude quickly. And the stall speed remains a docile 67 knots, making it forgiving for less experienced pilots. But none of these specs matter if the competition beats you to market with something better, and that's exactly what was supposed to happen with the Beechcraft Denali. Emphasis on supposed to.
Textron Aviation announces the Beechcraft Denali with massive fanfare, a clean-sheet single-engine turboprop designed to destroy the PC-12's dominance. Larger cabin, more modern avionics, lower operating costs, and a price tag of $6.45 million, undercutting Pilatus by hundreds of thousands. The aviation world watched and waited. 2018 rolls around. No Denali. Textron promises delivery soon. 2020. Still no Denali. Certification delays blamed on the GE Catalyst engine, a brand new turboprop engine that was supposed to revolutionize efficiency. Except it wasn't ready. Not even close. 2022, the Denali finally flies, and industry insiders start whispering. The GE Catalyst is having serious certification problems. Fuel consumption isn't meeting targets. Reliability testing keeps revealing issues. Textron stays quiet publicly, but privately they're panicking. 2024, 10 years since initial development began, the Denali still hasn't delivered a single aircraft to a paying customer. Meanwhile, Pilatus has sold hundreds more PC-12s and is preparing to launch the PRO. Here's what makes this absolutely brutal. Textron spent over $1 billion developing the Denali. They bet everything on the GE Catalyst engine being superior to the proven Pratt & Whitney PT-6. But the PT-6 has over 64,000 engines in service worldwide, with more than 1 billion flight hours accumulated. It's the most reliable turboprop engine ever built. GE Catalyst has zero operational history. As of early 2026, the Denali is finally approaching certification, but Textron has missed the entire market window. Pilatus dominated for a full decade without serious competition, and now the PC-12 PRO has features the Denali can't match. No Autoland, no G3000 Prime, no established support network. Beechcraft built a competitor for a market that moved on without them. This is what happens when you gamble on unproven technology while your rival perfects what already works. But working technology means nothing if pilots and passengers don't want to sit inside it for hours. That's where the cabin becomes critical.
Pilatus brought in BMW Design Works to craft the PC-12 Pro interior, and the marketing photos look absolutely stunning. European leather seats with custom hand stitching, panoramic windows flooding the cabin with natural light, a flat floor stretching nearly 17 feet. Executive office meets luxury lounge at 30,000 feet. But let's talk about what those brochures conveniently omit. The cabin width is just 50 inches at shoulder level. For comparison, a Cessna Citation CJ3 jet gives you 55 inches. You're paying $6.8 million for a cabin narrower than aircraft costing less. Sit 2 large adults side by side and you'll understand immediately. This isn't private jet spacious, it's comfortable turboprop, and there's a difference. The seats borrow design elements from the PC-24 jet, which sounds premium until you realize they had to shrink everything to fit the tighter fuselage. Taller passengers will appreciate the improved headroom, but legroom in the aft seats still gets cramped on longer flights. Now, here's where Pilatus actually delivers on the hype: versatility. This morning, you're carrying 8 executives in leather-appointed luxury. This afternoon, you've stripped the seats and loaded cargo through that massive palletized door. 4 feet 5 inches by 4 feet 4'. That's bigger than most SUV cargo areas. The flat floor means you can slide equipment in and out without fighting steps or awkward angles. Tomorrow, it might serve as an air ambulance with medical equipment installed. This adaptability is genuinely impressive. But there's a catch nobody mentions. Reconfiguring from passenger to cargo takes trained personnel and the right equipment. It's not a 5-minute job like Pilatus suggests. You need proper restraints, the correct loading procedures, and weight and balance calculations for every configuration. The 6 available color palettes and custom options let you personalize the interior, but customization adds months to delivery times and tens of thousands to the price. That $6.8 million base price, it's just the starting point. By the time you add everything you actually want, you're pushing $7.5 million easily. Which brings us to the question everyone's actually wondering: is this thing worth the money? $6.8 million. That's the advertised entry price for a PC-12 Pro. But let's break down what you're actually buying and what it really costs to own this machine. Operating expenses run between $1,200 and $1,500 per hour for moderate utilization. Fuel, maintenance, insurance, hangar fees. Sounds reasonable until you calculate annual costs. Fly 300 hours per year and you're spending $360,000 to $450,000 just to operate it. That's before loan payments if you're financing. The 600-hour maintenance intervals and 5,000-hour engine overhaul periods help control costs. But here's reality. That first engine overhaul on the Pratt & Whitney PT6E67XP will run you around $800,000. Yes, $800,000. And that's assuming no unexpected issues. Now let's talk about the value retention everyone keeps praising. 10-year-old PC-12s retain approximately 80% of their original value. That sounds incredible compared to cars or even jets. But do the math. You pay $6.8 million today. 10 years from now, your aircraft is worth roughly $5.4 million. You just lost $1.4 million in depreciation alone. Add in all those operating costs over a decade, and you've spent well over $5 million just to own and fly it. Here's the part that really stings. Current delivery backlogs stretch 2 to 3 years. You place your order today with a deposit, and you won't see your aircraft until 2028 or 2029. By then, who knows what Beechcraft finally delivers with the Denali, or what other competitors develop. You're committing nearly $7 million to an aircraft you won't touch for years, betting the market doesn't shift underneath you. The first PC-12 Pro was delivered to an Australian operator in September 2025. That's one aircraft. Production is ramping up, but Pilatus can only build so many per year. High demand means long waits, and long waits mean uncertainty. But here's what you're really paying for: access. Those 5,000 airports that jets can't reach, the ability to land on grass, gravel, and dirt, the versatility to switch from passengers to cargo, the proven PT6 engine with 1 billion flight hours backing it up, and yes, that Autoland system that could save lives. The question isn't whether the PC-12 Pro is capable. It absolutely is. The question is whether that capability justifies the cost when alternatives exist. And after everything we've uncovered, from the Wyoming tragedy to the Denali disaster to the real operating expenses, there's one final truth we need to address.
So here we are, the Pilatus PC-12 PRO, the most technologically advanced single-engine turboprop ever certified, an aircraft that can land itself if you're incapacitated, a machine accessing remote airports where multi-million-dollar jets can't follow. Swiss engineering wrapped in luxury that rivals aircraft costing twice as much. On paper, it's flawless, but we've seen what happens when perfection meets reality. 7 people lost their lives in a PC-12 when automation failed at the worst possible moment. Investigators are still asking questions nobody wants to answer. Pilatus responded by loading the PRO with even more computers, more sensors, more automation. The Autoland system is genuinely revolutionary. It will save lives, but it also represents a fundamental shift in aviation philosophy. We're trusting machines to make life or death decisions at 30,000 feet, and that trust comes with consequences we're only beginning to understand. The competition tried to challenge Pilatus and failed spectacularly. Beechcraft wasted a decade and over $1 billion on the Denali, betting on unproven technology, while Pilatus perfected what already worked. That's not luck, that's strategy. But strategy doesn't erase the uncomfortable questions. Is single-engine reliability really superior to twin-engine redundancy? Or is that just clever marketing? Can automation genuinely make flying safer, or does it create new vulnerabilities we haven't anticipated? Is $6.8 million justified for an aircraft with a 50-inch wide cabin and real-world limitations that brochures conveniently ignore? The PC-12 PRO doesn't just represent the future of turboprop aviation, it represents our willingness to embrace technology we don't fully understand because it promises convenience and safety. Maybe that's progress, or maybe we're building systems so complex that when they fail, we won't be able to save ourselves. Excellence in aviation isn't about the shiniest cockpit or the most advanced autopilot. It's about getting people home safely every single time. And after everything we've uncovered, that's the one promise no aircraft can truly guarantee. The PC-12 PRO is remarkable, but remarkable doesn't mean perfect. And in aviation, anything less than perfect can cost everything. Now, I want to hear from you. Would you trust your life to Autoland technology after what happened in Wyoming? Do you think Pilatus has truly solved the automation problem? Or are we just adding more complexity to systems that should be simpler? Drop your thoughts in the comments below. If you're a pilot or aviation professional, I especially want your perspective on single-engine versus twin-engine reliability. And if this investigation opened your eyes to what's really happening in aviation, smash that subscribe button and hit the bell so you don't miss our next deep dive. We're exposing the truths the industry doesn't want you to know. Next time, we're investigating why private jet manufacturers are hiding critical safety data from buyers. You won't believe what we found. Until then, fly safe, question everything, and remember that the most expensive aircraft isn't always the safest one.